Good morning again, sixes. So I wanted to put together an idea for you because I think it'll help you generalize what you know to not just a couple shapes, but many, many, many shapes that we can now do things with, both in 2 and 3 dimensions, using the exact same concept that we've been working on this last week. So here's the idea. I want to start by looking at area of a rectangle, and I'm going to look at a length on a line and then an area of a rectangle to try to get visual sensibility of why area equals base times height works for a rectangle. So like, why does that work? Well, on a number line, we know how to number the units, obviously. So if this is 0 and we count it out, this is 5. But like, why is that space really 5? There are several good reasons we could give to something like that. One of the good reasons we could say that that is 5 is when a point begins at 0 and that point animates along the line to get there, the space that it crosses is 5 units. So it's really 5 because if we think about this 0-dimensional object, that point, and if that point animates through this space, there's 5 units of space, and that's what defines that as 5. Okay, well, using instead of 1 dimension, like a line, we can move into 2 dimensions where this has a length and a width, or a base and a height, however you want to think about it. So if our base is 6, how would we look at this the same way to say, like, what's the whole area of the rectangle? Well, I would think this thing is 6, and as I take this space and I animate through here, I'm acquiring area. Like, if I animate through here, I've acquired the area there, but none of the other area. And there we can count up the area. This is 1 square, 2 squares, 3 squares, 4, 5, 6. So that is 6. And as I animate through another 1, I get another 6, and another 6, and another 6. And if I count those all up, then I would see this height is 4. And because that height is 4, the whole area then has to be 24. And I guess I didn't put units. I should say units and units, which would make this units squared. So, but that gives you an idea why. Like, why does area work this way? Well, it's because we have some base, in this case 6, and as that base animates, it acquires area. So here it is acquired 6 units there, and then 6 more, 6 more, and 6 more, and when we add those up, we get the 24 units. Well, when we move to a three-dimensional object, when we move to 3 dimensions, it works the exact same. Volume of a prism is the same. So we know how to do rectangular prisms, but you haven't looked at a prism like this. However, we can use the same sensibility argument to develop what should happen. If the area of this base is 6, then as I take that base and I animate through here, well, it should be acquiring area. Or sorry, acquiring volume, because the area is 6. As we had a 3rd dimension, it's acquiring volume. So if I take this and I cut it, that's 4, so that's 1, 2, 3, and 4. Then the volume we've acquired here is 6, because it moved up from, like, down here we just have an area of 6, so a volume of 0. But when I animate through 1 space there, I now have 6 volume, and then 6 more is 12 volume, and 6 more is 18, and 6 more, so the whole thing ends up with 24 volume. And we get this great formula, which is the volume of a prism like this is the area of the base times the height. And what we see here is it doesn't matter what shape this base has. Like, that would work for triangles like this, but if I were looking at a rectangular base, I could think about this the same way. I would just be thinking of this rectangular base animating through space, and as it fills this area up, I gather all that volume. So it's the area of this base times that height will always get it for me. But this is true even if I have strange objects. So this would be less common. But let's say we have some weird, like, I don't know, oblong object like that. And this thing, I'm really bad at this. Maybe I'll go down because I don't have much space above. Come on. So if I go down, we have some sort of prism made of this thing. So, I don't know. Some sort of I don't know, something like that, where this thing connects. Well, if we wanted the volume of that whole thing, we just have to know what is the area of this. In this case, we don't know. But if, let's say we knew that area is whatever, A. Then if I take that area A and I multiply times this height, I would get the entire volume in this whole three-dimensional object. All of that would be added up if I multiplied the area of this base times that height. So overall, here are 3 area and volume relationships that you should know and memorize. Now, I don't require my students to memorize much. We should be able to make sense of most things, and when they make sense, you don't need to memorize them. But here are some things you definitely should memorize. I'll start at the bottom is actually, no, the middle one is the most fundamental. We know the area of a rectangle is the base times the height. And we know really that works because the base and the height are perpendicular to each other. So that's why we can do base times height. The area of a rectangle, or sorry, area of a triangle is 1/2 of the area of a rectangle. Just saying whatever triangle we've got, we could double that area and we get that rectangle. So it's always half of that. And then the volume of a prism is the area of the base times the height. Well, that happens because whatever base I have here, the height is perpendicular to that base. So we end up with prisms that we can take the area of this base, multiply by the height, and we get the whole volume. Let's look at your guys' assignment for the day. Here it is. So you'll see they're doing the exact same thing I am. They're trying to find the base shape as a triangle, so they find the area of that triangle. It was 12 centimeters. So the volume, they multiply that 12 centimeter base, which is this triangle here, times the 12 centimeter height, and it kind of animates this triangle through, and we get all of that volume. I want you guys just starting at problem 1, getting these volumes. You can see like this is pretty simple. Here you have the area of the triangle multiplied times the height, area of the triangle multiplied times the height. You'll have to cut this into 2 pieces, but that's easy. You've done that with area, so now just do it with volume. Question 2, the exact same ideas, but now there are missing measurements. So you know the area of this base, for example, and you know the whole volume, but you're going to have to divide to find that height. Great, so go for it. Yeah, I want you just getting through problems 1 through 4, and if you get through 4, that's totally fine with me. If you want to keep working, that's great as well, but that's the assignment for today. That's all I got. Have a great day, 6s, and I'll talk to you soon. Bye-bye.